our understanding of causality and temporal sequence. If you traveled back in time and prevented your grandfather from meeting your grandmother, then you would never be born, which means you could never travel back in time to prevent their meeting, which means they would meet after all, which means you would be born, which means you could travel back in time. An endless loop of logical contradiction that seems to tear holes in the fabric of cause and effect itself. But the grandfather paradox is just one example of the temporal impossibilities that emerge when we take the mathematics of space-time to their logical extremes. Einstein's equations permit closed time-like curves, paths through space-time that loop back on themselves, allowing travelers to arrive at their own past, to become their own ancestors, to create causal loops where effects precede their causes and outcomes determine their origins. These aren't just science fiction fantasies. They're mathematically valid solutions to the field equations of general relativity, suggesting that the universe itself might contain pathways through time that violate our common-sense understanding of before and after. The implications extend far beyond time travel stories. If closed, time-like curves exist, then the very concept of cosmic history becomes problematic. Did the Big Bang cause the present state of the universe? Or did the present state somehow cause the Big Bang? Could the universe be participating in its own creation, reaching backward through time to establish the initial conditions that would eventually give rise to the very circumstances that reach backward through time? The universe might be like a bootstrap paradox, writ large, a self-causing system where every effect is also a cause, where the beginning depends on the end and the end determines the beginning. Quantum mechanics adds another layer of temporal strangeness through the phenomenon of retrocausality, the possibility that quantum measurements in the present can influence the past states of particles. In certain quantum experiments, the choice of measurement made in the present appears to determine which path a photon took through a double-slit apparatus in the past, as if the particle somehow knew what measurement would be made and adjusted its historical behavior accordingly. This isn't just correlation. It's a violation of our basic assumptions about the flow of time and the direction of causation. The delayed choice quantum eraser experiment pushes this temporal weirdness to its limits. Photons are sent through a double-slit apparatus, creating an interference pattern that suggests they traveled through both slits simultaneously. But then, using quantum entanglement, experimenters can choose whether or not to measure which slit each photon passed through. And this choice can be made after the photons have already hit the detector screen. Impossibly, the choice made in the future appears to retroactively determine whether the photons behaved as waves or particles in the past. These experiments suggest that the past might not be fixed, that history itself might be subject to quantum uncertainty, that the universe might be constantly rewriting its own timeline based on measurements and observations that occur later in time. If this is true, then the end of the universe might somehow influence its beginning. The final state of reality might help determine the initial conditions from which everything emerged. And the cosmic story might be told both forward and backward simultaneously, with past and future locked in a dance of mutual causation that transcends our linear understanding of temporal sequence. The measurement problem in quantum mechanics reveals another fundamental paradox at the heart of reality. Quantum systems exist in superposition states where all possible outcomes occur simultaneously.